Okay, so your pendulum, period, proportional to square of length, period, 5 when length is 2, what's the period when length is 6? And we want to solve this using the shape of the graph of the appropriate basic function. Since it's proportional to the square of length, we're going to put period here, length here, and we know that the shape of this thing is going to be like the x squared function, right? Okay, so we construct an x squared function, but we don't label the axes because we're going to want the axes to be labeled according to our data. We're still going to do points just like we would do. Okay? And since all the numbers here are positive, we don't need to draw the negative side of this graph. So all we need to do is put a point here for 0, 0, put a point like here for 1, 1, and then go up 2, 3, 4, and put a point like here for 2, 4, and a quarter of this height for this. You could even use 1/2, 1, and 2 and label it and then erase your labels or cross them out or something, okay? Because the labels on our basic squaring graph are not going to be helpful except for graphing the curve. So we graph the curve. Here we go. Does it look about right? Well, naturally, I drew it. I never draw bad graphs. It must be that way. Okay. Now what do? Well, we want a point on this graph that corresponds to period 5 when the length is 2, right? Okay? So we're going to want a point where the length is 2. We're also going to need a point where the length is 6. So we're not going to call this 2 because our graph goes up off the board at that point, right? Draw the graph big enough and then we confine ourselves to whatever we've drawn. Because we're pretty sure if we're careful in locating these points, we've got a pretty good shape to the graph. Something that we can use to make a reasonable estimate and to understand reasonably how this proportionality might work. Again, it's the wrong proportionality for the pendulum. It's not the squaring, but we're going to use it anyway. Because that's what it said to use. Okay, so we want the point 2, 5, right? So we plot the point for 2, 5, remembering that we'll need a point for x equals 6. Meaning we don't put 2 all the way out here. We got 2 shouldn't go more than a third of the way out here. So we're going to put 2 right about, let's just say 2 is, we can put 2 here. And where are we going to put period 5? Well, that's going to have to be on the graph corresponding to x equals 2. So there's 5. Now, does that make sense why we would do that? Okay, should. If not, ponder it. Okay? And we did this. We did this about a week and a half ago, maybe 2 weeks ago, almost a week before last. Okay, so we have this point. Well, now we can put a scale on our graph. We've got a scale for our graph. Here's 2, here's 5, right? Well, if this is 2, then you go twice that far, that'll be 4. You go twice that far, that'll be 6. And you can go twice that far, that'll be 8. But, we don't really have a curve above 8, so it's a good thing we didn't ask anything for 8. Okay? And we got 5 here. Well, we double that. That gives us 10. Now let's just mark off in units of 10. So there's a scale for our period. Now what do? We want to know the period when the length is 6. How do we do that? Well, here's length 6. We just project up, project over. We see the period might be about 40. Okay?
My graph's inaccurate.
Our 2-5 point tells us how the axes have to be labeled. This also reinforces something. It's a common error at the beginning of a pre-calculus course. People will just put any number anywhere on a graph. They won't even attempt to make a consistent scale because they've probably done everything on a computer where the consistent scale is automatic. Or just never understood why the scale has to be consistent, okay? So, yeah, I have to write a lot of notes on inconsistent scales, but, yeah, people straighten it out. You shouldn't come into this course with that. Something's wrong out there. And something's always wrong, you know. You go into the next course, you find something was wrong with this one, you know. Not throwing stones that don't come back and hit me too, so. But you gotta be aware of that. Okay, so we label, and then estimate the period for length 6.